Hello. We have a requirement from a HR consultancy firm, and they want to identify the factors which would affect the attrition of an employee for a company. So they have a huge data set, and this data set is split in several files. So the first aim was to create a single consolidated data file, and to create a single consolidated data file, we had to start with, as usual, data preparation and data cleaning exercise. So what we started looking was if we can identify one column which can be common and which can be used to merge all these all these different dataset files. We zeroed upon a column named as employee ID, and we found that this employee ID was a unique column. It had all unique values in all the data and on all the class files. In all the data files, and so we could use it to merge the different data files. This column also had no missing values, and then again also we looked for missing values in the data files, and for missing value imputation we used a WOE analysis. I will talk on this a little later. So coming back to the data preparation exercise, we had one file which was actually recording the time in and time out period of an employee, and it has another column which was the employee ID. So for each employee it was giving this was the time in and this was the time out, and this was recorded for full 1 year, for all the days of a year. So what we wanted to do was to have a column which could which could give us a figure of how many hours a particular employee worked. So if our employee worked more than 8 hours, we created one additional column. If our employee worked more than 8 hours, we say that it has a value greater than 1, and if he worked less than 8 hours, we say that this column has a value 0. By calculating this column, we added this column in the main data file, and this is how we also took the factor of the work hours into our consideration, since this was also the data given to us. This is how we use the in time and out time data. Then we also find some columns which were having the same values for all the observation of the data. So we decided to remove those variables since they would not help us in our model generation analysis. Since we thought they will not help us. After this, the other approach which we used was to create the dummy variables for some of the variables. For example, there were variables which had some limited set of values, so we created dummy variables for these variables. Now coming to the missing value imputation or the any values data handling, what we did was we created a custom method which we used to calculate the WOE for a variable, and we also this what we used use this method to understand if we can replace the missing value by the WOE values. We also did checks that for each variable the WOE is a monotonic trend, has a monotonic trend, because we wanted to have kind of classes which follow the particular monotonic trend. There was course classing and binning also done on all these variables which were subjected to the missing value imputation analysis. So all the WOE the variables which were used for WOE analysis, they were also subjected to course classing and binning. So finally we had this is how we removed the NA values, so by replacing the NA values with WOE values. Then after this we went ahead to split the data into test and train data in 70:30 proportion, and then we ran the usual logistic regression model in this case. Why we opted for the logistic regression model was because we just wanted to understand the probability if a particular employee will leave or not. So we thought that logistic regression would be best in this case. So starting with the model generation, we use the step IC with both backward and forward propagation approaches to get a first list of dependent variables. Then we move ahead using the criteria of high VIF and high P values. If a variable has a high PIF and high P value, high VIF and high P value, we remove that variable. We also did plot the correlation plot between these variables to understand the correlation between different variables. We found that list of in 30 models we found a list of around 10 variables. Then we start to evaluate the model. We started drawing the confusion matrix, and on this 13 model, what we found was so for plotting the confusion matrix, first of all, for finding the prediction, we choose the cutoff for cutoff probability as 0.5, and using the model 13 model, we generated the predictions, and we found. And then on this prediction we run the confusion matrix, and what we found was that accuracy was high, but the sensitivity was very low, and the specificity was also very high. We wanted to have not that low sensitivity. It was as low as 19%. So eventually what we thought was we have to improve the cutoff values for the probability. So in order to decide the threshold for the cutoff probability, what we did was we varied the cutoff. We wrote a function which actually varied the cutoff probability and took values from 0.5 to 0.9, and for each of this value it plot the confusion matrix and gave us the figure of sensitivity, specificity and accuracy. Then the cutoff value which we chose, the cutoff threshold value which we choose, was the one having minimum difference of 0.01 between sensitivity and specificity. So what we found was the cutoff probability which was meeting this requirement of minimum difference of 0.01 was not the minimum difference but the maximum difference, sorry, was 0.1. So cutoff probability came out at around 0.185. Then we draw a confusion matrix on this, and we found accuracy, sensitivity and specificity to be in good numbers, which can be considered better. Then we also plot some lift charts and also curves to show that our model is able to distinguish between no model and our model. So if you get a random model, we were able to show that if we use our model, it will give you better results, predictions, compared to if you don't use any model. Then we further used a K-stat table, which we used to draw to evaluate the KS statistics, and what we could found was that our model can help us in identify 79% of the employees who will leave by targeting only 40% of the workforce. So if you could this was very meaningful for the business. So what we told to business is that if you identify these 40% of your workforce and you take some positive actions on this workforce, you will actually solve 79% of your attrition rates. This is how we help the business. Thank you.